So we're looking at lesson 11.1, basic concepts of probability. Okay, we're going to understand basic terms of probability. We're going to look at theoretical versus empirical probability, understand the law of large numbers. The more times you roll the dice, okay, the closer the probability, the empirical probability, which is the actual versus the theoretical, the closer they get. Find the probabilities of related genetics. We're going to be getting into probabilities with genetics and determine the odds. So, and we're going to look at compare and contrast odds versus probability. Okay, probability is basically you're looking at something that's random, a random phenomenon. If you were to go out and pick randomly, look at, as students walk by, maybe ask them, do they live here local, or do they live in a different state? Do they live in North Carolina versus a different state? And you pick out randomly people that pass by. This would be a random occurrence or random phenomenon. And so probability is based on, what we look at in events that are in a random occurrence. Okay, so probability is an experiment is where we're looking at either rolling a dice or flipping a coin or picking a card. So the study of probability of if we're observing something, measuring it randomly, that's an experiment. The result of the experiment is an outcome. The result of the experiment is an outcome. And so the sample space is all possible outcomes. So if we were to roll, for example, a dice, we can either roll a 1, a 2, a 3, a 4, a 5, or a 6. That would be the sample space for rolling one dice. Okay. If you're rolling two dice or two die, then you've got die 1 and die 2. You've got 36 possible ways of rolling two dice at the same time. So this would be a sample space of two dice, okay? Rolling two dice randomly, okay? So this right here is a deck of cards, right? You've got hearts, diamonds, ace, clubs, ace through king. So this would be a sample space of a deck of 52 cards, okay? All right, any questions with that? Okay, so we'll refer back to those from time to time. So usually when we are interested in some particular collection of possible outcomes, then any subset of that collection is an event. So, in other words, experiment is where we're looking at maybe picking marbles out of a bag, okay, or straws out of a bag, different colors. Whereas if you were to take, that would be considered an experiment. Whereas if you're looking at a particular collection of possible outcomes, then that's an event. All right. So a single ferret coin is tossed. Find the probability that it will land heads up. Okay, so the way probability works, so we're looking at probability of success. And success means whatever it is we're looking at. It doesn't mean good thing or bad thing. In this case, success would be flipping a coin, getting heads. So that would be the number of ways of possible successes over, so this would be, the numerator would be the number of possible successes over the number total ways of, in this case, flipping a coin. So if we're looking at the probability of flipping a coin and getting heads, then we look at how many heads there are in a coin over the total number of the total. So in this case, there's one head on a coin, right? Over total is 2, because the sample space for a coin is either a heads or a tails, right? So the total is 2, but there's only one head. So the probability of flipping a coin and getting heads is 1/2, right? Or 0.5 or 50%. Okay? Normally, we either look at it as a fraction or a decimal, but I like to use percentage because I think people tend to relate better to percentages. Now, probability is either going to be less than or equal to 0, is going to be greater than or equal to 0, but less than or equal to 1. So, as a decimal, your range is from 0 to 1. Okay? All right. Any questions there? So here we have the sample space, heads or tails, in the event whose probability we seek is for heads. So probability of heads, this is probability of event, meaning heads that we're looking at is 1/2. So this would be known as a theoretical probability. Now if we were to take a coin and flip it, let's say 5 times, we may get 4 heads and 1 tail. Well, that's not 50%, right? But if we do it over a long period of time, then it will come out closer and closer to 50%. I had a class where we did a lab with, we rolled 1,000, everybody, I had 5 groups, and every group had 20 die. And we'd roll the dice. Everybody rolled their dice at the same time, and we calculated up. And we rolled the dice 1,000 times. So basically, each time we rolled, that was 100, and we did that 10 times to come up with 1,000. And what we found out is, the more times we rolled, the closer and closer the difference was between actual probability, what we had, for 1s and 2s and 3s, and the theoretical probability. And so that worked out pretty well. Okay. So this is what I was showing on the board here. Number of favorable outcomes or number of successes over the total. So this is where we were working with counting. In the last chapter, n is the number of favorable outcomes or number of events over the number of total outcomes. Okay, a cup is flipped 100 times. It lands on its side 84, its bottom 6, and its top 10. Find the probability it will land on its top. Okay, so you have side 84 times, bottom 6 times, and lands on its top 10 times. Okay, so, and we want to find the probability that it will land on its top. Probability top. Okay, so the way this works is you want to write out like a table here. So we said before that it landed inside 84 times, bottom 6 times, top. So you always, now they gave you the total, right, which is 100. Okay, now they're not always going to give you the total. This time they did. If they don't give you the total, you always have to figure out what the total is, because that's always going to be your denominator. Okay. So we want the number of times it lands on its top over the total. So how many times what are we going to put in the numerator? Number of times it landed on its top, 10. Over the total, which is 100, right? So if we were to cancel out the zeros, right, simplify, we'd get 1 over 10, right? If we divide that, we get 10%, or 0.1, right, or 0.10 or 0.1, which is 10%. Okay, so that's why I like to use percentage along with decimal, because people tend to relate with percentages better. Okay, so this is an example of an empirical probability where it was actually performed. Okay, empirical probability where we're actually, in this case, flipping a cup versus maybe rolling a dice. So when I told you we did an experiment with 1,000 rolls, that would be considered an empirical probability. And we were comparing empirical versus theoretical probability, and for 100 rolls it was pretty close to like 5% difference, but as we rolled more and more it got closer, and it got more like down to 0.1% and so on by the time we got to 1,000. So that was it just showed that it got closer and closer. Okay, so empirical so again, number of successes over the total. Number of times the event occurred over the total. Again, basically it's just number of times that event occurred over the total. So the total is always in the denominator. Okay. There's 2,598,960 possible hands in poker. If there are 36 possible ways to have a straight flush, okay, find the probability of being dealt a straight flush. So you're looking at probability of a straight, okay. So we're looking at probability of getting a straight, right? 6, 7, 8, 9, 6, 7, 8, 9, 10 of the same suit or whatever straight, right? So we're looking at the number of times we had a straight over the number of total possible hands. And so that was 36 different ways to get a straight over 2,598,960. So that if you divide that on the calculator, okay, let's do that. We've got 36 divided by 2,598,960. And here it shows it in scientific notation, right? So they show 1.385. So this would be times 10 to the negative fifth. Okay, that's what that E is. So if you took that, your decimal, and moved it, right, you would move it 4 places to the left. 1, 2, 3, 4. And so that would be 0.000, 1, 2, 3, one more, 4, 1, 2, 3, 4, one more, 5. So that would be 0.00001385. And so they rounded that up to 139. Okay? But that's the probability. So that as a percentage, right, you move that 2 places to the right, 0.00139%. So the probability is pretty slim of getting it straight, okay? So that just the chances of getting it straight are pretty slim. And a squiggly looking equal sign means approximately equal to, because it was rounded off, okay? Any questions with that? Okay, school has 820 male students and 835 female. If a student from the school is selected at random, what's the probability that it will be a female? Okay, so if we went out there and here at Livingstone, let's say we have male, let's say we had 820 males, and females, we have 835, so I'll just use M for male and FM for female. 835 female, and we want to know what is the probability of selecting a female. Okay, well, we need to come up with, we need to do what first? Find the total, right? So that'd be 5, right? 5. So that'd be 5 and 5, 8, 16. So that's 1655, right? So we want the number of females over the total. Okay. So what are we going to put in the numerator? Yeah, 835. So that's, make that a little clearer. 835 over 1655. And so if we calculated that out, right, so let's do that on the calculator. 835 divided by 1655, and we get 0.504. So basically, it's pretty close to 50%, right? 0.50, we'll round it up to 5. Pretty close to 50%, right? That would be the same as 50.5%, right? Questions? So most of the time, you only see it as a decimal. But if you want to get a better idea of what the probability is, you know, you could always just move that decimal point over 2 places and you got percentage. All right, any questions there? All right, the law of large numbers. And that's the law of large numbers. All that means is the more times you do an empirical event, like I said that we rolled the dice 1,000 times, the larger the number of times you do an experiment, the closer and closer your empirical probability becomes closer and closer to the theoretical probability. Okay, so that's the law of large numbers. All right, comparing empirical and theoretical, series of repeated experiments, empirical probability versus theoretical is what we're doing, successes over the total. Okay. All right. Genetics, a Austrian monk, Gregor Mendel, looked at pea plants, and some were red and some were white, and he was able to discover the genetics. Theory of genetics from it, where he symbolized capital R with red and lowercase r with the white flowers. Okay, and what he found was that there were more times it showed up red than white, and we're going to show why. Okay, so we have 2 parent plants, one of them that has pure red and one of them that's pure white. So let's see. So we've got pure red is 2 uppercase R's. Pure white is 2 lowercase r's. So from here, we went ahead and put together what we call a Punnett square, where we have parent 1 is red and parent 2 is white. Okay, so the way this works is you get 1 gene from parent 1 and 1 gene from parent 2, so you get uppercase and lowercase. So, and then this would be uppercase and lowercase. So when you have a large R and a small r, this is going to turn out red, but it has a carrier of a white gene. So uppercase and lowercase is a red plant but it carries a white gene. Okay, it's red, it's still red, but it carries a white gene. And so that's why you could have two red plants and you put them together and they can possibly produce a white plant. That's how you end up sometimes with a white plant. Okay, so here this is going to be uppercase and lowercase and uppercase and lowercase. So two parents, one red and one white, produce all red, and this is our first generation. Okay, so we take the offspring. So the offspring, do that in a different color. So we take all these offspring. We take two of the offsprings. Doesn't matter which ones, just two of them. And we run it again. Offspring. And so this is parent 1 and parent 2. And so this is uppercase and lowercase. Lower this a little bit. Uppercase, lowercase, uppercase, lowercase. Okay, so we run through this again, and this time we have uppercase and uppercase, right? So this is pure red. This is red, does not carry the white gene, it's just pure red. So what's the next one going to be? Uppercase and lowercase, right? So this is red, but it carries the white gene. Okay? So what's the next one going to be? Capital R and lowercase r again, right? Whether it's uppercase, lowercase, or lowercase, uppercase, really doesn't matter. So this is red, but it carries the white gene again, right? Now what's the last one going to be? Yeah, lower and lower. So this is why you can have two red parents and still end up with a white flower, an offspring with a white flower in it. Okay? And so that's what this is here. That's what they're showing here. Okay? Questions with that? So the parents, they're the first generation, the offspring are the second. Here, the parents are the second generation and the offspring are the third. That's why it's first and second, the second and third. Like that. So the outcomes, right, are outcomes for the third generation is red, 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 pure red, red carrying a white gene, there's two of them, and white. Okay? All right, questions with that? So the probability of getting a red, right, would be number of red over the total, which would be, how many red do we have here? 3, right, over a total of 4. So it's 0.75, right? So if you did white, right, use this board. If we looked at white, probability of white, what would that be? Here's our sample space, right? how many, so this would be the number of white, right, over the total. Okay, so how many white do we have here? 1 over total of what? 4. So as a decimal, that would be what? 0.25, yeah. Okay, or 25%, right? Okay, questions with that? So that's how we tie genetics into our lesson on probability. Okay, questions with that? All righty. And so that's what we did there. Okay, next, odds. Odds are different than probability. Odds compare the number of favorable to the number of unfavorable outcomes. So odds are commonly used in the racetrack. But on the racetrack, they put odds, they use odds against. And so lotteries, they use odds as well. All right, so odds, so let's look at the difference between odds and probability. Probability of an event is the number, or let's use successes, is the number of successes. In the last case, success would be considered number of red or number white, right? If we're looking at the probability of white, success would be number of white plants versus the number of red over the total. Whereas odds looks at the number of successes over the number of not successes. Or you could even call them failures, but they're really not a failure. It's just, it's not what you're looking for, okay? It doesn't mean anything bad. It just means what you're looking at versus what you're not looking at. So, all right. Odds of the outcomes in a sample space are equally likely. A of them are favorable, and the remaining B outcomes are unfavorable. So, for example, we said the probability of a red plant was 3 over 4, right? So basically, odds would be number of red to number not red. In other words, that would be total minus red. So the odds of red, we had 3 red to not red, which is 1. So the odds in favor of getting a red plant is 3 to 1. Okay? Odds against a red plant, you just flip it. So you just, if you want odds against, just look at odds in favor and flip it. Okay? So that's the easiest way to find odds against, is to find odds in favor and then just flip the numbers. Okay? All right, questions with that? All right. Okay, so 200 tickets were sold from a drawing to win a new television. If Matt purchased 10 tickets, what are the odds in favor of Matt winning? All right, so let's look at that. So Matt purchased 10 tickets. There's a total of 200 tickets. Okay? So you have to look at, for the odds of, so the odds of getting a TV set, okay, are going to be a number of tickets that Matt purchased, right, to number that Matt does not have. So Matt has 10 tickets, right? So to find what Matt does not have, we take the total, 200 minus 10, right? And so that would be 190 altogether, right? So the odds would be 10 to 190. So if we looked at it like a fraction, right, you could basically cancel out the zeros, because it's like dividing 10. So basically, the odds of Matt winning a TV are 1 to 19. Okay? Also written as 1 to 19. So the odds against Matt getting a TV, Matt win a TV, are what? Odds against. Is what? Yeah, 19 to 1, right? And that's what a horse, if you're going to the horse races, to bet on the horse races, they're going to use odds against. So, you know, you want to keep that in mind if you're going to go to the track. All right? Questions there? Okay. So, if we wanted probability of winning a TV set, that's the number of tickets Matt bought over the total. Well, Matt bought how many tickets? 10. The total tickets is what? 200. So that's, again, if you cancel out the zeros, you get 1 over 20. So you see the difference between probability and odds? Here, this is success and failure. Tickets plus not tickets, right? Total. Whereas here, with odds, you're looking at number of tickets Matt has to number of tickets Matt does not have. See the difference? The total is the number of tickets Matt has and the number of tickets Matt does not have. Okay? Questions there? Okay. All right. So here, suppose the probability of rain today is 43%. Give this in terms of odds. Okay. So I'd like for you to try this one. Okay. So probability that it will rain is 43%. Okay, so we want this in odds. So basically, you change this from percentage to a decimal, and then from a decimal to a fraction. And then from there, you can find the odds. So again, odds. So probability of rain is number of days that it rains over the total. Odds are number of days that it rain to number of days that it not rain, which is the total minus number of total minus number of days that it rained. Okay, so I'm going to leave that with you for right now. See if go ahead and try that. I'm going to get attendance here real quick. All that darn thing. One, two, three, four, 5, 6, 7. Okay, so Amante not here, Tyree not here, Jada not here, Joey not here, Jayla not here. Ahmad not here, Zaire not here, Juan not here, Joel not here, Kenneth not here, Kelly and Joseph not here, Jasmine not here. All right. Okay, let's see how we did. All right, so basically, we said the probability for rain is 43%, right? So as a decimal, that's 0.43. So that's the same thing as 43 over 100, right? Because percentage is that number over 100, right? 0.43 is 43 over 100. Okay? So this would be, so the number of days that it rained is 43. Total days is 100. Number of days that it not rained would be 100 minus 43, right? So if you took 100 minus 43, right, that'd be 7, 9, 4, that's 5. So that's 57. Okay, questions with that? So the odds that we would get rain, probability is 43%, but or 0.43. The odds are going to be what? To what? Odds in favor of it raining. Yeah, 43, right? Number of days it rained, number of days that rained, to number that it did not rain. So that would be 43 to what? 57. So that's odds in favor of it raining. How about odds against rain? What would that be? You just take these two numbers and what do? Flip it, right? Yeah. So it's 57 to 43. Odds in favor, odds against. So next time you go to the track and you see odds against, you can just flip it and see what the odds in favor. So the racetrack says, my dear Aunt Sally horse, odds are 100 to 1. Are those good odds that she's going to win or bad odds for my dear Aunt Sally to win the race? That's bad, right? Out of 100 races, she won 1, right? So, yeah. So now you know. Okay. So odds against, so we want to find the probability, suppose the probability of rain today is 43, give the information in terms of odds. So here's probability for rain, and they gave odds in favor and odds against. Okay. All right. Good exercise on that one. Your odds of completing college algebra class are 16 to 9. What is the probability of completing the class? 16 to 9. Okay. So we said here to complete our college algebra, the odds of completing it are 16 to 9. Now, if they give you odds, that's odds in favor. The only time, so if they say odd, so if they give you odds, that's odds in favor. Okay? So the only time you'll know if it's odds against is they will say odds against. If they don't say odds against, it's odds in favor. So this is odds in favor. Okay? So, but the probability of completing is the number of that complete over the total. Well, this is complete versus not complete, right? 16 completed, 9 did not complete. So how do we, what's our numerator going to be? 16, yeah, because that's the number that's the same number as this, right? But we need a total. So we got to figure out what total is, right? Well, what's our total going to be? I'm going to give you a minute to think of that one. Yeah. It's going to be number completed plus number not complete. So that's going to be 16 over 25. So that's going to be 16 plus 9, right? 16 plus 9. 16 over 25. Okay, so we wanted to figure that out as a decimal. Put it in the calculator, right? 16 divided by 25. We get 0.64. Right? Or basically what percentage? Just move the decimal over. To figure out percentage, just move the decimal over 2 places. So what is that as a percentage? 64%. Yeah. Okay. That's all you got to do. Questions there. But they'll ask for it in decimal form. I like to go ahead and figure out percentage too. Okay. Questions there. All right, let me see something here real quick. Yeah, we'll do that. Okay. Here's a wheel. Okay. We have this wheel here. And one, two, three. We need one more. So here we've got C, and then the rest of them are B, D, A, B, A. Okay. And we want the odds of, so this is a spinner, right? So basically, if we took a needle, we have a needle on here and we spin it, and we want the odds of spinning it C. Okay? So basically, we're looking at the number C to number not C. Well, how many C's do we have on our spinner? 2. So we put 2 here. Yeah, so basically that's 8 minus 2, right, or 6. So if we were to look at it as a fraction, right, we could simplify that to, well, 2 can go into 6 how many times? 3. 2 goes in itself once, right? So we could simplify that to 1 to 3. So the odds in favor of spinning and landing on C is 1 to 3. Okay? All right. The probability so in other words, the probability of landing on C is what to what? 3, careful now. Probability is the number of C over the what? Total, right? Probability, the denominator is always total in the denominator, right? Always. So, how many C's did we say we have? 2. Over, what's our total? 1, 2, 3, 4, 5, 6, 7, 8. 2 over 8. So that's going to make it 1 over what? Over 4, right? Because 2 goes in 8 4 times. So that's 1 over 4. So that's the difference between probability and odds. Okay? So with probability, you're taking, another way to write this is 1 over 1 plus 3. 1 over 1, the first one, over the sum of both of these. Okay? Because that's your total. Because remember now, this is number what we want versus what number that we don't, bless you, number of C's versus number of not C's, right? Simplified out. Okay? Okay, so do we need to see another